All right. So we finished up Unit 2 last week. If any of you are still working on assignments for Unit 2, you could still turn them in and still get credit for that unit. And last week you should have received an email with a comprehensive list of all the homework that was due for the unit. So it was basically all the mastery tests for Unit 2, plus we did 2 sets of questions on paper. And that can be found in your email or at the end of the videos from last week. So I'm calling this lesson Graphing Parabolas. Graphing Parabolas. This is a continuation of what we've been doing in Unit 2. All the work we did with all the work we've been doing with factoring quadratics. Well, now we're going to start graphing those expressions to see what those shapes are like. So today will be some definitions and then a little bit of work to translate those expressions. Okay, so what we'll be covering today: parts of a parabola, vertex form of a parabola, vertex form. I want this to work. There we go. This is all over the place. Just one moment, please. There we go. Now I'm getting something. Okay, so we're going to look at the different parts of a parabola and how we'll use those. The vertex form, that's really important too. We'll compare that to standard form, which is what we've been working in so far. And then a couple key parts of the parabola. So finding the vertex, finding the axis of symmetry, and finding the zeros. This is a big one, an important one. Finding the zeros of a parabola. Okay, so quadratic trinomials from Unit 2. These are also just called in math quadratics. So in our tests or mastery tests or anything from Inventum, and I'm probably going to call them this sometimes too. If we just use the word quadratic, we're basically talking about a quadratic trinomial. Okay, same thing. And we're talking about things in this format. Our polynomials, right? We've been just calling them our second degree quadratic polynomials. We've been factoring these. That was the main point of Unit 2, was to take this expression and be able to factor it to something like this, where these are numbers here in those spaces. Well, these are basically called a quadratic. And I just want you to be ready if I slip up and just call it a quadratic, or definitely our curriculum will refer to them as quadratics. And what do they mean when you read that or see that? It just means the polynomials that we've been working with. So when graphed, oh, this is a mistake. When graphed, these are called parabolas. So when we take our ax squared plus bx plus c and we set that equal to y like this, And of course, A, B, and C would be numbers. If we had numbers in for A, B, and C, and we set that all equal to y, well, now we can graph this expression, and we get this shape that's called a parabola. So we're going to dig into these today and look at the different parts and look at the beginning of how to graph them. They're going to make this shape. This is the parabola shape. It's kind of like a U or a bowl shape. Maybe it's facing up, or maybe it'll be facing down. We'll look at how to know the difference if it's an upward or downward facing one. But these are the parabola shape. Where it's coming from is graphing our quadratics or our polynomials that we've been working with in Unit 2. Any questions so far? Okay, get ready. I want you to copy this down, the next example I've got. So take a moment and sketch this parabola on your paper, please. Doesn't have to be perfect, doesn't have to be exactly like mine, but I do want you to have the same main parts here. So start like this. I want you to have an x-axis, so a left-right line, and let's mark that all the way from -3 up to 10, evenly spaced out. So how I would do this on just plain paper is make a line and then start on the left with like your farthest spot, so -3, and then just pick a small size that'll be 1 unit, and then move up one at a time. So -3, -2, -1, next one is 0, and then just keep going. Hopefully you've got enough space to get to 10. And if not, let's just keep those spaces evenly spaced out and see how far you can make it. I guess we want to make it till at least 5 or 6 or 7, ideally. Look at that. When I made mine, I'm not even getting all the way to 10 either. So it's just kind of a do your best. And we can always restart. I don't want you to spend too much time making your graph though. All right, so there's your x line. And then you're going to obviously make a y-axis going through 0. So wherever your 0 is, that's where the y-axis is going to go. So make that go straight up and down. And let's make sure that that goes at least from like -2. So I'm going to start going downward, -1, -2. And let's see if we can make that go all the way up to 8 units high. So 1, 2, 3, 4. I just barely got mine up to 8. So whenever you're making a graph or a sketch of a graph, we have to obviously have the XY axis there. Now to make your curve, your parabola shape, I want you to follow along while I do this. We're going to graph a couple special points. And I'll wait a few moments just in case people are still making their XY axes. In fact, what I want you to do, please, is give me a confirmation when you have your XY axis ready to go. And then we'll move on.
I have it, Josiah.
Manaya, thank you.
I have it too, Josiah.
Janessa, I see that in the chat. Thank you.
Me too.
Awesome. Thank you. Aaron? Was there anybody else ready yet?
Yeah, I'm almost done with it. I'm just doing the y and then I'm done.
Awesome. Braden, thank you. I've got it up on my screen how I did it by hand, just as a model, because I know, we haven't graphed together yet. Maybe it's been a while for you too.
I got it, Josiah.
Sorry, I missed that. Who was that?
Who's Lay?
Leja. Thank you for letting me know. We're going to graph in just a second. We're going to graph a couple key points, and then we're just going to connect the dots. And that's, I think, the easiest way to graph these parabolas by hand. Someone else in the chat here. That's okay. Keegan, I just want everyone to practice graphing this with me. And then you'll have a model that you can look back to for later as well. So start with the X, Y lines. It's okay if it's not perfect. It's okay if it's not exactly like mine, but we do want to have enough space to get some of the parabola on there. So start with these lines like I did in red here. Hopefully everyone can see that okay. Okay, now for our model, let's continue. And I want to start with putting our special points down. So let's do this. This is called the vertex. It's at 3, comma, -1 for this example. They're not always like this, right? This one is at 3, -1. So that means start with X. We're going to go 1, 2, 3, and then down the second number, in this case 1. So let's go to 3, -1. So graph that spot for me on yours. Three, -1. And then we're going to do two spots that are close to that. We're going to go 2, comma, 0. So that's 1, 2 spaces over to the right, and then 0 up or down, so right on the X line. Here's that one. Check out my screen for a model. And also 4, comma, 0. So I'll label those. 2, comma, 0 and 4, comma, 0. Okay, now we're almost done graphing this. We also have another usable point here that'll be helpful, and that is going to be the y-intercept, where our black line, and I'm going to label these in a second, and we'll talk about it, where our parabola is crossing over the y-axis. On my black picture, my black line, that's right here at 0, comma, 8. So let's put that on our drawn one. 0 left, right, but up to the 8 spot right here. Check out mine for a model. And that'll help us make it curvy and not like a straight line. We want it to have some smoothness to it. Now, one more thing I want you to follow along with me on. Go back to the very first point we did. It's called the vertex, 3, -1. That first point, it's the lowest one we graphed. Let's make a straight up and down dashed line. Watch me do it. Remember, it doesn't have to be perfect. It's your first time, so don't be hard on yourself. But just try your best, and I'm sure it'll be fine. I'm making a dashed line straight through that vertex, vertical, straight up and down. Now here's the deal. The reason we did that line, that's got a special name. It's called the line of symmetry. So when we have a parabola, and we'll talk more in a minute about like where this is all coming from. But when we have a parabola, it is all evenly split right down the middle, like on the left and right, like a mirror image. So if we look at our 2, comma, 0 and our 4, comma, 0 points, those are each 1 unit away from the line of symmetry. And so that 8 or 0, 8 up here, this location is going to be 1, 2, 3 spaces away at the same height. So I'm going to kind of try to measure that out. I'm going to go 1 space to the 4 is right below it, and then 1 more space to the 5, and then 1 more space to the 6, just like there's 3 spaces away on the other side. Okay, you don't have to put those arrows there, but I'm trying to show you how I'm using the line to measure away from the line. So I think it should be 6 comma 8. Let's put our final point here, 6 comma 8. I'm just using the line of symmetry to kind of see where that should go. Now, finally, if you've got 5 points graphed on your picture, we're going to connect them. I like to start at the bottom, the vertex, and I'm going to draw one side up and make it curvy and connect to those 2 spots. Remember, it doesn't have to be perfect, and it's okay if yours is not. It's your first time. Then we do the same on the other side. See, look at mine. Mine's not perfect either. It's a little wobbly. I don't want to leave anyone behind. So I'm going to wait on here for a moment, and then we're going to label some parts. Okay, I've been talking about some parts of it, but we haven't labeled it. I want to wait until I know that you guys are ready. So if you can give me confirmation when you're ready with your picture, or if you have questions, need help, need to go over any part of it, need clarification, please tell me, and we'll move on.
Josiah, should we show you our notes that we have so far?
Totally, yeah. If you want to show me what you got, I'd love to see it.
Okay.
Oh, Leja, that is really nice looking. Good job. Thank you. Any questions, Leja?
No, I think I got it. Thank you, Josiah.
Yeah, of course. Good job. Thank you for trying, for following along. You did a great job. Does anyone else want to have any questions, concerns? I don't want to leave you behind. I want everyone to have this, model in your notes that you can look back to later. So it's important that we have something to label and follow along with. So if you're stuck on this, if you have questions, just tell me. It's all good. You're probably not the only one. I guarantee you. Can you all please do what Leja did and show me your notes in a moment when you get a chance, so I know you have something ready to move on with, please. All right, Delaney, thank you. Perfect. Thanks, Delaney. See that, and I see Aaron's. Good job. Thank you, Aaron. Janessa, that is stupendous looking. Thank you. Braden, I got you. Okay. Okay, thanks everybody for showing me that. Keegan, awesome. Okay, cool, Keegan. So I'm going to go over these points, Keegan, but these are the 5 points that we use to kind of make our picture. So the graph you have is perfect looking. Start with this one, Keegan. 3 comma negative 1. So starting from like the middle where you've got your 2 lines intersecting, we're going to go over to positive 3 to the right and then down 1. And that's called the vertex. So start with that spot, please. And then I made two points above it at 2 comma 0 and 4 comma 0. So that's like 2 to the right and then no up or down, 4 to the right and no up or down. So right on the X line. Then we did 0 comma 8. That's on the top left of our picture. And from that point, or that like time, we could basically do the left side of our picture. And then I wanted to show everyone we've got this middle line that's dashed going right through the vertex. And what that line's doing, everybody, is splitting our picture into 2 like equal parts, 2 symmetrical sides, mirrored images. And so we can, if we know one side, like the 0, 8, then we can use our line of symmetry to measure to the other right side. So I did that here for 6 comma 8. I see something in the chat. Yes to that question in the chat. what I'm going to do is actually erase my red one, and we're going to use the same picture I have in black, and I'm going to label that. So it's the same graph, everybody. So please don't worry. It's the same picture you have up, and I'm going to do the points again on my black one. So let me do this. And if you have questions, please interrupt and ask. It's okay. So we started with the vertex. And so please label your picture along with me. This is the vertex. The vertex is basically the spot right in the middle of your parabola where it changes direction. So on mine, well, on all of ours, on this example, it's going from left to right, down, right? We're heading downhill fast. And then it hits the vertex, and then it turns and goes back up. The vertex is the highest or lowest point. It's the bowl. It's where it changes direction. Okay, now let's talk about that middle line before we do any other points. So it's not in my picture, is it? There's no like dashed line. I'm going to put it in again, though, like I've asked you to do. It always goes straight through the vertex, cutting the parabola into two halves. This is called the line of symmetry, or maybe it'll be called the axis of symmetry. Okay, so line of symmetry or axis of symmetry, same thing. Line of symmetry. It's cutting it into like two equal parts, two equal sides. That's important. It can be useful just for graphing it by eyeballing it like we did today. And it does come into play with some different formulas that we'll be using later. So that's the line of symmetry or the axis of symmetry. And then two other important spots we used were 2, 4 and 4, 2, 0 and 4, 0. Now these are important spots. These are the x-intercepts. X-intercepts. It's where our parabola is cutting through or crossing the x-axis. These are also called the zeros. We're going to refer to these a lot as the zeros, okay? This is where y is equal to 0. See, if you look at our y ruler, the y-axis, we've got 1, 2, 3, 4, 5 going up, and negatives going down, but right in the middle is y is equal to 0. Y is equal to 0. So when we call the x-intercepts the zeros, we're doing that because it's when y is 0, this x is 2 and x is 4 in this example. So those are important, and they can be useful just for graphing it as well. Any questions right now? Talked about the vertex, the line of symmetry, the x-intercepts, also called zeros.
I have a question.
Yes, sir. Go for it.
So the vertex won't always be the middle of something like this, right? Or the line of symmetry. I mean,
You're saying it will or it won't?
like it won't always be in the middle of the shape after we're done doing the graph, right?
Yes, it will always be in the middle.
Oh, okay.
It'll be in the, pardon me, it'll be in the middle of like the graph itself, like the bowl shape.
Oh, okay.
Does that answer your question?
Yeah. And then will there be different shapes other than this bowl shape, or are we only working on this one today?
We're only working on this one today.
Oh, okay.
And frankly, of this whole unit. So all the work we've been doing, folks, with our parabola or our polynomials, remember how all of Unit 2 was factoring polynomials? When we graph those, it turns into this bowl shape. So all the work we've been doing so far is kind of leading us up to this point. so that we can graph these things. This is just the next step. Does that help, Braden?
Yes, it does. Thank you.
Okay, yeah. Yeah, this is the only shape we should have to worry about for now. Yeah, later when we get to other units, we'll look at other stuff, but for now, it's just this. We also talked about the y-intercept. On our example, it's this spot here, 0, 8. This is our y-intercept. If you remember back to Math 1, when we were graphing like straight lines, the y-intercept was really important for those as well. Remember y equals mx plus b, and that plus b is the y-intercept. So this is going to be useful and important to us as well, the y-intercept. Now, here's something interesting to notice. A parabola is only ever going to have one y-intercept. Like if you took my black parabola here and you kind of moved it around, like let's say we could grab it and drag it across the screen. It's only going to cut through the y-axis once. If we dragged it over and set it, put the vertex on the y-axis, it's going to cut through just once right there. If we moved it far to the right or far to the left, it should only cut through once. But we have two zeros. Notice that. We have two x-intercepts where it's cutting through. Any other questions or comments or concerns right now? Does anyone want to go back and talk about just making the graph? Any questions? Okay. Does anyone need a little more time on this screen before we move on? Okay. All right, then let's move on. So we've just talked about these parts of the parabola. Now we need to look at the equation of a quadratic, of a polynomial that we've been working with, and see how we can graph this thing just from the equation. Okay, we're going to start with this, and this is new for you. This is called vertex form of a parabola, okay, or of a quadratic. Same thing. Vertex form. So please copy this down as well. So this is the generic equation for a parabola in vertex form. And then in a minute, we'll look at standard form and connect the two. So y is equal to little a, lowercase a, times parentheses x minus h. And that parentheses is being squared, raised to the second power, plus k. That's it. Y is equal to little a times x minus h quantity squared plus k. Now, if we have a parabola or a quadratic in this form, in vertex form, where what you'll be looking for is x, is there x minus a number or x plus a number? And is that in a parentheses to the second power? That's basically all we need for it to be in vertex form. If you have an equation in this form, then the h and the k spots, those are telling you the vertex. H, k is the vertex. Now, this is going to come up more in tomorrow's lesson, but I want to start talking about it now. The a number, if there's a number being multiplied to the parentheses, there isn't always one there. Then it would be a 1. But if there is something there, this is the same as the capital A from our old form. So that's something. It's the same as the capital A in our old format of a polynomial. And the A is telling you if it's upward facing. So if A is positive, then our parabola is going up, like the one we had in our example. If A is negative, it's facing down. So we know a little bit about the shape of our parabola just based on the equation in vertex form. We should be able to look at it and know where the vertex is, looking at h and k. And then the a number, if there is one, is telling you if it's upward or downward facing. So before we look at another example, I want to just draw, I'm going to do another practice example with you. So I'm going to draw a line here just to make some space. So here's an example of a parabola in vertex form. I guess we'll call this example 1. So let's say we had y is equal to x minus 10 squared plus 20. X minus 10 squared plus 20. Notice that it's not 10 squared, it's the whole subtraction, x minus 10. Parentheses is all being squared. So this is our h number, and 20 is our k number. So the vertex of this would be 10, comma 20. In the formula, it's built in as x minus h from above. Notice that. So the vertex, the x portion of the vertex is actually, it's like the opposite sign of whatever it looks like it is in there with the x. It's always opposite. So since this was x minus 10, well, it's positive 10 in our vertex, okay? It can get a little tricky. I think practice will be the best thing for us for finding the vertex. And then the k value is always taken at face value. So if this was positive 20, then it's positive 20 in our vertex. But for the h, the first number, the x portion, that's always opposite sign. So if that's minus 10, it'll be positive 10 in our vertex. Okay, no questions right now. For this next part, I've got another parabola graphed, and I'd like you to just examine this with me. Instead of copying it down, I want you to just examine this with me and see if we can identify the vertex, the axis of symmetry, and that's always going to be, I didn't mention this earlier, it's always going to be an x equals, like a line, x equals some number, okay? Vertex, axis of symmetry, the x-intercepts, also known as the zeros, and then the y-intercept. I want to find these different parts. So examine this picture with me. And if you see the vertex and can label it and name it for me, please let me know. And same for the rest. So let me know if you can answer any of these, please.
Josiah, with the axis of symmetry would be the line down the middle, right?
Exactly. Good.
So would it be like -1 and then +4?
Wonderful. -1. Yeah, it's the number that's right down the middle. So that -1 you noticed is right in the between the parabola, from the lowest
Yeah.
part of it to the highest part of it. It's also going to be going right through that vertex. Good, like you said. So for axis of symmetry, it's x equals -1. Let me get that thing out of the way. X is equal to -1. That's our axis of symmetry. Now, you kind of mentioned it. I'm not sure if you were saying it and I missed it or not. For the vertex, do you have an idea on that, Leisure?
It'd be 4
Yes.
or
4 is like the height of it, right? Right here.
no,
And-
-1 and 4.
yes. And just remember, we always list the x part first and then the y. So it'll be -1, comma, like you said, -1, comma 4.
Yeah.
Good. So there's our vertex. And then you got the axis of symmetry. Does anyone else, or Leisure, do you or anyone else notice what the x-intercepts are? Where is our parabola cutting across the x line, the x-axis? And remember, there's always going to be two of these. There should be two x-intercepts, 2 points. Can anyone take a stab at that for me?
Can I try?
Yeah, please.
Is it -3 and 0?
Perfect. -3, 0. That's this one right here.
Yeah.
And then did you get a second one?
Yeah.
Okay.
Oh wait, is it 1 and -0 or 1 and 0?
1 and 0. Yeah, that's this spot right here.
Mm.
Good. Now, notice, Leisure and everybody, we're really just looking for like, what is the number where it's crossing over? -3 was this one, and 1 was this one. And then the y portion of that x-intercept is always 0. Always. So it's going to be a -3, 0, 1, 0. Like the height of that point or coordinate is always 0. And that's why we call these the zeros. That's part of like the name. We'll look a little more at that as we move on. Then the y-intercept is this spot right here. Y-intercept, it's where our line is cutting through the y-axis, and that is at 0, 3 for this example. Now, just for fun, I'm going to add on another part of this like example, and that is let's put together the equation for this using vertex form. So I'm going to put that at the bottom, vertex form. Back on the last slide, we had that listed. So it's y equals a times x minus h squared plus or minus k. So the vertex is telling us what h and k is. The vertex here was -1. But remember, the formula is x minus h. Here, I'll put it in generically again here. A times x minus h squared plus k. So that x minus is kind of always changing the sign of what it looks like the vertex should be for h. So in this case, it's going to be x plus 1. Remember, x plus 1. It's going to be opposite of what it looks like it should be from our picture. X plus 1. And that's because it's x minus -1. That's what's happening with the math there. X minus -1 is making it into plus 1. And then for k, it's plus 4. Remember, the k portion is always at face value. meaning it's just like it looks like in our picture. The h portion is always opposite sign of what it looks like it should be. And I'm kind of oversimplifying this for this example, but there's a is 1 here. And we'll look more at that later. That's a little more complex, and I wanted to wait on doing the a part. So it's just 1, so here's our formula for this example. X plus 1 squared plus 4. Okay. If there's no questions or comments, there's a little bit more I wanted to look at with you, finding zeros. Now, Leja, thank you so much for helping out. You did a great job of locating those zeros from the graph. What I want to do next with you all is find zeros when we don't have the graph, okay? When we are only working with the formula. Okay, I mentioned this earlier. X-intercepts are also known as the zeros. X-intercepts, that's what we're looking for, is where the parabola is intercepting the x-axis. Finding zeros without the graph. Now, that's our goal, our mini goal for this lesson. Besides all the definitions and graphing we did, is to be able to find zeros without the picture, without the graph. Now, there's nothing wrong with using the picture, but we just want to be able to do both. I want to be able to identify them from a graph and from just the equation. So we're going to go, instead of vertex form, I want to go back to our standard form. So here's our first example of finding zeros. Here's our quadratic, y equals x squared plus 2x minus 35. So all through Unit 2, we learned how to factor this expression. We turned it from this format with the A, B, C format into the two parentheses, right, being multiplied together. And that's how we find the zeros. So I'm going to really quick factor this like we've been doing in Unit 1 until we can get it down to this point right here. Y is equal to parentheses times parentheses with x plus and x minus some number. So let's factor it first. We've got negative 35, and they have to add to a positive 2. So I make my list, of multiplies to negative 35, and then adds to a positive 2. 2 doesn't work, 3 doesn't work, I think 5 works, 5 times 7. And notice that the space between 5 and 7 is 2, so this is probably going to be our winner. It's got to be a positive 2. They multiply to a negative, so that means one of the numbers is negative. So that means it'll be negative 5 plus 7, and that does equal positive 2. So negative 5 and a positive 7. So we split up our 2x, and we factor. We pull out x, and then for the second set, we pull out 7. And then we factor out x minus 5, and we get x plus 7, x minus 5. So to find the zeros without a graph, we want to factor our polynomial, factor our quadratic, just like we've been doing, okay? So do Unit 2 stuff, factor it down to this point. And now the question is, what values of x make each parentheses into a 0? So really quick before we look into this more, I want to show you another side example. So let's just look at this example with me real quick. Let's say we have two numbers. Let's call them, oh, I lost somebody. I don't want to call them A, B, and C, and I don't want to call them X and Y. So let's call them, darn it, H and J, I guess. No, I don't. L and M. Okay, L times M. So let's say we were multiplying two numbers together and they were equal to 0 when they're multiplied. Okay, so L times M is equal to 0. So that means either L is 0 or M is 0. And now look back over to the right, and that's what's happening here. When we're trying to find the zeros of our quadratic, we've got parentheses times parentheses equals 0. Now, I have it written as equals y, but looking at the picture again, at the x-intercepts, and I pointed this out earlier, at this x-intercept and this one, well, what is the height there? That's y equals 0. So when we're solving for the zeros, we're essentially making y into 0 like this, and then solving the equation for x. Because it's split up into these two factors, the left parenthesis and the right parenthesis, we are basically setting the entire parenthesis equal to 0 and then solving those mini equations for x. So continuing on the right side of the screen, at this point we're saying, okay, x plus 7 is equal to 0. What is x? X is negative 7. Then you say, okay, the other one, x minus 5 is 0. What is x? X is positive 5. And here, x equals, we've just found the two zeros of this quadratic. So we know that at x is negative 7, if we were to graph this thing, there's one of the zeros, and then x is positive 5, like right here. We don't know too much else about this parabola yet, but we know that's where it's crossing over. So we factor, we get it down to the two parentheses, x plus 7, x minus 5. And then we're basically just saying set each of those equal to 0 separately, solve it for x, and we get our zeros, our x-intercepts. This was just a side example to explain kind of the philosophy of why we're doing that. If two numbers are multiplied and their product is 0, that means one of them, maybe both, but at least one of them has to be 0. So that's why we set them each equal to 0 and solve for x. So it's nothing really too new or too crazy, I think. We're just factoring it like normal. So on the right side, everything up to here, right here, this is all normal. This is all unit 2 stuff. And then at this stage, we're taking those parentheses, setting them equal to 0, and solving for x. And those are the zeros of the quadratic. Okay. Now, what if here's an example 2. What if we're given a polynomial in vertex form and told to find the zeros? So if it's in vertex form instead of ABC form, well, what do we do? Well, it's the same as what we just did in example 1, except we have to put it first into standard form. Standard form is ABC form. So how do we start? We're going to multiply out the x plus 2 squared. Remember, x plus 2 squared means parentheses times itself. So I'm going to expand that. I'm going to multiply those together. Bring down the minus 25. And now we just multiply like we started doing in the beginning of Unit 2. So x times x times 2, 2 times x, and then 2 times 2, minus 25. Bring down your stuff. Combine like terms. 2x, 2x, that's plus 4x. Okay, and then 4 minus 25. Those are like terms, so that's minus 21. And now, check it out. We have our A, B, C form, standard form. Let me write that down. So we've just gone from vertex to standard form, and now we can factor it and turn it into parentheses times parentheses. It didn't count as that earlier because we had that minus 25 hanging around, and we need that to be incorporated into the rest of the problem. And we did that by writing it fully in standard form. It turned into a minus 21, but that's okay. That's truly what it was. So now we're going to factor it. So 3 times 7, I think, is what are going to be our mix this time. So I'm going to skip that step, but I made my list and I found 3 times 7, and we'll make it plus 7 and minus 3. X plus 7, x minus 3. So I am skipping the step. You all know that process of factoring, making our lists. And here we are. So now the zeros. So you can do this a little faster if you don't want to set it all equal to 0 and solve each time. Look at the first parentheses with me. This guy. What value of x would make that plus 7 into 0? What would I want to add to 7 to make it equal 0? Anybody?
-7.
Yes, absolutely. Thanks, Leja. -7. It's the opposite of whatever the sign is, whatever it looks like is inside those parentheses. And for the next one, x with x minus 3.
X plus
+3.
Positive 3, thanks to both of you. Yeah, so there's our two zeros of this quadratic. The extra step came at the beginning. We had to put it into standard form. Later, so this was all like our extra step right here. Later, we'll learn how to go from standard up to vertex form, which is a lot of fun, but more steps. This is the main goal for today, is to one, I'm going to back up, hold on, is to be able to look at a picture, a graphed parabola, and find all the important parts. I want you all to be able to locate the vertex and state it like we did here. Locate the axis of symmetry and name it. It's always going to be x equals the number that's cutting the parabola in half. Of course, we want to be able to find our x-intercepts, the zeros, and then sometimes they'll ask us for the y-intercept. So this is our main goal for today, and also this process of finding the zeros with just the formula or just the equation in either format. Now, I think that should be enough to be ready for the mastery test. It's not called graphing parabolas. They're calling it quadratic relationships. It's mastery test number 1. We're in unit 3. Basically the first mastery test. Now, of course, you're all going to get slightly different questions, but they're all going to be just like what we've done today. So a lot of it is giving you pictures, and you have to identify the different important parts like we did. Then you also may get work on finding the zeros just from the equation, just from the formula. So give that a shot today. I'd like you all to try that. And then tomorrow, if you had any questions on it, we can either go over those together, or you can just tell me the number and maybe we can look at it in the afternoon together. But either way, try it today so that way I'll know kind of how everyone feels about this and how everyone did, so I can know if we need to how long we want to go over this. Any questions, concerns? No, no questions, concerns. Okay. Let me mark you all down for being present. All right, Hunter was here.